Okay, we will solve the following exercise. Exercise is the number 2.35. The magnitude of the position vector RBA from point B to point A is 6 millimeters, and the magnitude of the position vector RCA from point C to point A is 4 meters. What are the components of RBA? So what we have right here is basically a triangle. Triangle right here, and right here. It's basically all. Right here we have our points C, A, and B. The graphical representation is telling me that right here I have 3 meters, and the exercise is telling me that from point B to point A here I have 6 meters, and right here I have 4 meters. All right, now we have all the cathetus for this triangle. So because of that, I'm going to need to define the magnitude of the vector RPA using the components, which is actually what we need. Now, first I'd like to define every information that we need for us to do that, and basically all we have to do is to take these 6 meters and say that this vector is pointing towards this direction. So this is already telling me that the y component for the RBA vector, so RBA y component is going to be negative, and the x component is going to be positive. Why is that? Because I'm going to take into account this 0. That means that starting from this point I have my Cartesian plane, which means that towards this direction I have one part and towards this direction I have the other. Now all I have to do is to determine this magnitude and this magnitude. Alright, so I'm going to need this angle. I'm going to call it, for example, alpha. Now 4 squared is going to be equal to 6 squared plus 3 squared minus 2 times 3 times 6 multiplied by the cosine of alpha. Alright, now solving the equation, I have that alpha is equal to the cosine to the minus 1 power of 4 squared minus 6 squared minus 3 squared divided by minus 2 times 3 times 6. So alpha is equal to, let me see, minus cosine of 4 squared minus 3 squared minus 6 squared divided by minus 2 multiplied by 3 times 6. This is equal to 36.33 degrees. Alright, now we have right here a 90 degrees angle, and right here we have gamma, for example, which is equal to 90 minus the angle that we just calculate. So 90 minus the angle is going to be equal to 53.66. And now we have everything. This information, all we need to do is to say that y and x can be calculated. So in the case of y, is going to be equal to, let me see, the cosine of 53.66 is equal to y divided by 6. So y is equal to the cosine of 53.66 multiplied by 6. 3.55 meters. And in the case of x, we have that the sine of 53.66 is equal to x divided by 6. So x is basically the same equation but with a sign. Remember, you have to make sure that you are working in degrees. Now x is equal to 4.83. And now we go back to this part of the exercise. Now RBA is equal to 4.833 in the I direction minus 3.55 in the J direction, and this is in meters. And right here, guys, we have our final answer. This is how you can solve this exercise.